saw this question and thought this is absolutely horrible. You've got product rule, you have a sec here, you have an inverse tan. It's just repulsive. So we're going to be finding out what df du, df dv, and d squared f du dv. So for the, let's do df du first. So we have part A, so we have to break it up into u squared sine u plus v cubed. So that means we're going to use the product rule. Let's make x equal u squared, y equal sine u plus v cubed. That means x differentiated once is obviously 2u, and y differentiated once is going to be cos u plus v cubed. We now obviously use x y dash plus y x dash, so you're going to now get u squared cos u plus v cubed plus 2u sine u plus v cubed. So now let's start on part B, which is this horrible monstrosity. I know there's a negative here, but I'm just going to focus on this, and then we'll bring that negative back in later. So thankfully, because this contains a v in it and we're differentiating with respect to u, when you do partial differentiation, you hold the value that you're not differentiating as constant. You can almost ignore it. Let's say pretend it's like a 7 just sitting there, a number, a coefficient. Pretend it doesn't exist. So we're only going to look at the sec for u, contains a u, that's what we're differentiating. So d over du of sec for u is, I should write that out again, but we're not going to, is going to be, we need to actually recall something. Let's recall sec ax is actually equal to a sec ax tan ax. That is really sloppy. Hopefully that is readable, kind of. I'm not too sure. So d over du is going to be off sec for u is 4 sec 4u tan 4u. So now if you bring in this tan, you're now going to get, for that second part, you're going to get 4 sec 4u tan 4u dot, and then tan minus 1 2v. So df du is all of this and all of this combined. So we're going to get 2u sine u plus v cubed plus u squared cos u v cubed minus, because obviously remember we've got to bring that back in, 4 sec 4u tan 4u dot tan minus 1 2v. Obviously, this is going to be beyond horrific when we have to do df dv. So, df dv. So again, we're going to break it up as part A, which is u squared sine u plus v cubed. So we can obviously forget anything which contains a u in, and we're just going to be differentiating and looking at anything to do with v. So only obviously u squared doesn't depend on v, only sine u plus v cubed does. So you can almost pull this out of the differential and then bring it back in at the end. So d over dv of sine u plus v cubed is going to be cos Actually, I'll just skip through a little bit. 3v squared, obviously you differentiate this. We're using the chain rule, cos u plus v cubed. So we're going to now bring in our u squared. You're going to get 3u squared v squared cos u plus v cubed. So now for part B, we're going to look at this bit. Obviously, sec for u contains a u term, so we're ignoring it. We're only going to be differentiating tan minus 1 to v. So we'll just ignore sec for u, and that means d over dv of tan minus 1 to v. I have a whole video on differentiating and integrating inverse trig functions for sine, cos, and tan, the inverse of all three, differentiating and integrating individual videos. If you want to know how to do this step by step, please watch that video. So that's then going to be 2 over 1 plus 4v squared. It's just going to take too much time, and I'll waste too much time doing that instead of partial differentiation. So now let's bring back in the sec for u, and we would have sec for u dot 2 over 1 plus 4v squared. So if we now bring this all together, df dv is going to be 3u squared v squared cos u plus v cubed minus, and let's just put it up here, 2 sec for u 1 plus 4v squared. Now we're going to do d squared f du dv. We're going to need this solution. So what we're going to do is take this solution, and we're now going to differentiate this with just respect to v. So we're going to hold constant anything that has a u term in it. So if we do, there's d over dv of, let's say, 2u, so obviously this, 2u sine u plus v cubed, which is, we're going to ignore the 2u here, just differentiate this with respect to v. That's going to use the chain rule, so that's then obviously going to be 6u v squared cos u plus v cubed. I don't know why you would be watching this if you don't know how to do the chain rule, but there is a video on the channel going over the chain rule. And now let's move over to the next term, which is going to be this, and that's going to be u squared cos u plus v cubed, and that's going to be minus 3u squared v squared sine u plus v cubed. So obviously we have ignored this, we're just differentiating this again with respect to the v. And then finally we have minus 4 sec 4u tan 4u dot tan minus 1 2v. Obviously the whole of this contains v, so it only depends on this. So very thankfully we can just differentiate tan minus 1 2v, which we did with df dv, is going to now be 2 over 1 plus 4v squared. Obviously then you multiply this and bring it back into that. Now we have completely differentiated all of these terms, we just now add them together. So we're going to get df squared du dv, and that's now going to be 6uv squared cos u plus v cubed minus 3u squared v squared sine u plus v cubed minus 8. Yes, because 2 times all of that is minus 8 sec 4u tan 4u, all divided by 1 plus 4v squared. Okay, we're done. That is a stupid partial differential equation. partial differentiation, very tricky. If this was in a university exam, probably expect it in second year or first year university level maths, and I think it takes an inappropriate amount of time, so maybe a 6 or 7 marker, but still, once you do enough partial differentiation, it gets pretty straightforward.